Hey everyone, this is Muhammad Nadeem and welcome to my YouTube channel. Today in this video we will explore the concept of the electric current, and we will see that what is the origination of this electric current, and this electric current is mainly associated with the motion of these free electron. In this video we will know that what is the origination of these free electron and how these electrons start moving, which result the electric current. All these things will be discussed in this video. So let's start the video. Here we have a simple circuit which consists of the battery. Here the right side of the battery is positive charge, and the left side of the battery with the negative charge. And this battery is connected to a metal rod. Here it is labeled as a copper strip. So this is actually a copper rod. And we know that inside the copper there are millions and billions of atoms, and let's consider one atom from them, which is this copper atom. The copper have 29 atomic number, therefore here is 29 electrons revolving around the nucleus. Inside the nucleus we have proton with positive charge. That positive charge will attract the electrons because the electron had negative charges, and that electrostatic force is decreased when the distance between these two charges decrease. So here the electrostatic force on this last electron will be less, because this is present far away from the nucleus, and the electrostatic force is less. In this case, the last electron is considered to be a free electron, because it even free at room temperature due to this weak electrostatic force. Now here we have a large number of these copper atoms, and from each copper atom one free electron is contributed. So due to which here I'm going to draw that metal strip again and mention so let's say this is the metal strip, and inside we have the millions and billions of the copper atom, and each copper atom contribute a single electron. So here we have another copper atom which contribute this free electron, and in this way here are large number of the copper atom, and each copper atom contribute a single free electron. So therefore we can say that inside this metal strip there will be a sea of electrons. So by sea of electron I mean the free electron which is contributed by the copper atom in this case, because this is the copper strip. So this is the copper strip, and these are the free electrons present inside that copper strip. These are free electrons which are contributed by each atom of the copper atom. So here we have large number of free electrons, but if we provide the external source as a battery to it, so here I am going to connect this side to the negative terminal of the battery, and this side to the positive terminal of the battery. In this case these free electrons will feel force. That force is come from here. Due to electromotive force, potential differences is created, and due to that potential difference, electric field is developed inside this copper strip, and that electric field must be same everywhere inside this copper strip, and due to that electric field, the force F will exert on each and every free electron here, and due to that force these electrons start motion from one side to another, and that displacement covered by that free electrons per unit time is called velocity, and in this case this velocity is slow, and in this case we call that velocity is a drift velocity, and this drift velocity is usually per hours. So up to here we know that these electrons are in motion from the left side to the right side, and if I take the area inside this metal inside this copper strip, so I am going to take some area inside this metal strip, and that area is this. So inside this metal strip I consider this area, and now the number of free electrons passes through this area A the number of free electron passes through this area A at a given time is called electric current. Electric current is actually the electric current. Electric current is actually the number of charges. In this case, these free electrons passes through this specific area at a specific time. So that is called the electric current. The amount of the charges which are passes through this area per unit time is called the electric current. And the unit of this electric current is actually the coulomb. The unit of the charge is coulomb, and the unit of the time is second. And the coulomb per second is equal to ampere, and the unit of the current is ampere. So the unit of the current here is ampere. In some books, they call this current as the steady current. So here is the concept of the steady current. This is the current, and the current may be AC, alternative current, and it may be DC, direct current. This is the direct current, and this is the alternating current. And this current, the current may be AC and may be DC. This AC have the varying magnitude and direction. And DC current have only different having a varying magnitude. The direction is fixed, because if you see the battery have the fixed positive terminal and the fixed negative terminal. The direction is fixed, but they are varying in magnitude, and the alternating current is varying in both magnitude and direction. Now if we take the magnitude of the AC current is constant, magnitude of AC current is constant. By constant AC current magnitude, I mean that the frequency of the AC current constant. Then we call that as a steady current. Similarly, if I take the magnitude of the direct current as constant, we will call that as that also as a steady current. So from this we can conclude that steady current have the same concept as I discussed here, but we will consider the magnitude of the current as a constant. In another way, we can conceptualize it as the flow of these charges will, if we consider the flow of these charges as constant, then we call and pass them to through an area at a given time, we will call that as a steady current. In other words, we can say that if we take the density of these electrical charges as constant and considering them pass through an area per unit time, we call them a steady current. So steady current is actually associated with the constant magnitude, and that the constant magnitude of the current, but that current may be AC or may be DC. The steady current do not associate only with AC, or it do not associate with the DC, but it is associated with both. If we take only their magnitude as constant and taking their charge density as constant. So here is the concept of the electric current. And that's it, guys. Thanks for watching.